the Toronto Apache Spark. Holden's been here before. We always welcome you. The talks are, Holden is an engineer, a software engineer. She's a software engineer at the IBM. Talking about debugging Apache Spark. Thank you very much.
Thank you. Thank you all for having me, and thank you for coming. This makes it much easier for me to file my expense report later. So thank you for showing up. And hopefully you care about Spark, and if you don't, I'll try and be entertaining anyways. Is this just not all that loud? Can people hear me? Okay, I'll keep it close. Sorry. Okay, cool. So debugging Apache Spark, yay! They really have they're debugging their software, right? It's so much fun. That's why you're all here. You're like, yes, I'm gonna great. Okay, so I'm Holden. Pronouns are she or have it tattooed on my wrist in case you forget. And I am a software engineer at IBM Spark Technology Center. Spark committer. And if you have Python pull requests you want to try and get into Spark, please come and bug me. I would love to help you, or at the very least, like understand what you're doing. If you don't, that's okay too. I've got today's talk will go up on my SlideShare, assuming I remember. And once the video gets posted, I will add it to my playlist of Spark videos, unless this talk goes really poorly and doesn't exist, and I never add it to my YouTube list. Yeah. So I normally have America has been making me really sad lately, but I'm in Canada and I love Canada. I'm from Ottawa originally. Here. Incidentally, if you don't know other trans people, we're not. Please don't vote for people that think I'm evil. Not that there's too many of them in Canada. You know, I'd appreciate that on a personal note. So yeah, so IBM Spark Technology Center in a lot of money, which I'm happy to take some of. I keep trying to convince them to give me more, but mixed success on that one. If anyone's thinking about renewing a main, just like put my name down as the reason why. Perf cycle. But it's a technology center focused around Spark, which incidentally does actually, we're focused mostly on running it on standard commodity hardware. We've got people that focus on sort of Spark, on Python Spark, and we work on a bunch of as well. If you're looking to contribute to one of these related projects, work on some of them directly, and I can put you in touch with the projects if they're not one that I work on myself. I have a graph that goes up and to the right, which is how I keep getting paid. And so I work very graph goes, but essentially you can see that we've gone from like not contributing to Spark to contributing rather a lot to Spark. If you ask developers to close a bunch of JIRAs or make a bunch of commits, know that it's not too hard to make this graph go up and to the right. But I think there's some like really actual good work that's happening, and not just because they pay me. I have a graph that implies IBM does a lot of work in PySpark. This graph may be optimistic, but if you're considering a support contract or whatever it is, buy it. And that is the extent of me telling you about IBM. This person can do a much better job to meet one. But for now, I'm hoping you're all, you haven't been laughing at my jokes, and that kind of hurts, but it's okay. If pictures of cats or stuffed animals, you're going to want to just pretty much this part of my presentation from here on out. People know some Apache Spark, like you've used. Yay! Okay. Complete Apache Spark. Don't let this debugging talk turn you away. Debugging is always sad. And there are, I'm going to show you magical, happy things you can do with Spark that you should go watch afterwards. Cool. And get silly. I'm not very serious. So we're going to look at, and we really need to do to debug our job is normally figure out, we're going to look at our options for adding our own. And we'll talk about like how to understand some of Spark's common error messages. Are there any PySpark users in the house? So for those of you who are PySpark users, you've probably wrapped in Java exceptions, wrapped in Python exceptions, and it's read and know what's going on, right? And so wonderful 400-line stack trace and talk about the 6 lines in it that you care about and how to find those 6 lines. For like the fancy Java people, are there any like Java or Scala people in the house? So for you fancy JVM people, we'll talk about your fancy options. And for the Python people, we'll talk about the fancy options as good as the fancy Java options, and I'm sorry. I receive royalties for this. And corporate compliance training, which means that I'm not supposed to take 20s in an envelope, but I tell you to buy my book, and that's A-okay. If it, and lots of pictures of cats. Or, as I like to think it, we're going to build a monster identification guide. And so we've got a bunch of different monsters here, and one of them is with us today. Her name is Boo. So the Python worker stack trace. Friend monster represents the JVM stack trace. Tubbs, who's exception. And then Buddy, who is a really sweet dog, but mostly does useless stuff. Where am I? Oh my God, there's snow. Buddy represents the Spark logging. You get a little bit of some doing this, it turns out. But if you transform your cynicism into or at least that's what I like to tell myself. So finding our logs is pretty easy running in local mode. Admittedly, if we're just running in local mode, we're not getting any of the benefits of using Spark, but that's okay. Or if you're running bin PySpark or you're running the Spark shell, you get a lot of error messages reported to your console. You get probably to your console, you Googled how to turn off the logging information. How many people have turned off the logging from their console? Okay. How many people use the console and haven't turned off the logging? Wow. Okay. More than I expected. That's cool. So for those of you that don't want to turn it off, we can like dynamic our application is failing, but that's okay. If you maybe turned off the logging on your console, is you can go into the wonderful Spark Web UI or Spark History Server and get the logs from the workers there. You won't get your, unless you're running mode. Is anyone running an application master mode on Yarn? Okay, you and I, we're going to chat afterwards, but in a more normal deployment. So client mode. Okay. Does anyone like Jupyter for notebooks? Yay! I love Jupyter, and not just because they buy me coffee sometimes. But when I was talking at PyData, one of the participants told me this. The error messages were so useless, I looked up how to disable error. I got really sad. And Buddy also got really, I was listening to Buddy talk about snow. But essentially, that this bit contains only the useless parts. So what you see in your Jupyter console are only the parts of the message useful for debugging, and that's kind of sad. Shell, you can just go and look in your shell and you'll find your error messages. If you're running in a cloud thing, you can go look at your fancy cloud thing. If you're using something like Databricks Cloud, they did the work to actually plumb through the error messages to you. So you get 400 lines of junk, but 8 lines of 100 lines of junk without the 8 lines of content, which is okay, cool. Yarn people. Yay, friends. Log aggregation turned on. You can use the yarn logs command to just go. And I think it's really easy to set up the Spark history. So please enable it. It will make your life a lot easier. You can just yarn your logs, application dash log server is totally worth enabling. Likes debugging core dumps with you can enable it in here, and Yarn will not clean up your container. And you can log into the container and manually poke at stuff. Normally, you only have to do this if you're going down the path of sadness of like there's code and even realize was there because underneath everything still. So this is helpful for when you're about to. Yay! But okay, let's talk about happy things like how Buddy likes to talk to us about snow. Things we all or don't need to know. The S level is really convenient. A lot of the guides online should be logging information in the properties file, and you can totally configure your logs in the properties file. But if you sometimes working and then it gets to a part where it fails at log level, you can like turn off the like super verbose logging, the part of your job where things go kind of to hell, and then turn it you're about sadness, and this will help you out. And then Buddy won't talk nearly as much, but it'll tell you a few important things. So once we actually get our error and Buddy gives us our error message, depending on the error we've got, it's going to look kind of different. We're going to stack trace wrapping a Python stack trace, wrapping that JVM stack trace, and possibly direction if we're really unlucky. For JVM users, be lucky. Get a JVM stack trace, wrapping a JVM stack trace, and you just like have 50-50 odds on picking the right one. In general, if you only get back one stack trace, it's good because you just have one stack trace to look at. So much better. But what do, oh right, yeah. So Java Scala, normal stack traces. In the base you can ignore if you're getting a driver stack trace and a worker stack trace. And R in Python is pretty much the same, except we have need to ignore. So we're going to make an error, the simplest error I could think of. I'm going to divide by 0. Debug R by 0. It's not super exciting. It's going to help us a little. So we've got our bad transformation in Scala. This is going to throw, and then we're going to count. Super simple. Go ahead here, and then we get our error message. And what lines of crap I don't care about. The part that I do care about was right at the top. So I can just like look at the top. And this is because it's reporting the error that it's getting immediately. If I were to be looking at and I wasn't using a screen session or a notebook, all scroll would be kind of sad because I'd be left with a driver stack trace I care about. But essentially just like use a notebook or a screen session where you can go up and look at what came in. The same thing in Python. We've got lambda. Except instead of 100 lines, it's 400 lines. The top being useful, it's about how, which is true. Our iterator is sad. Our error is somewhere inside of here, but we don't get our useful bit right in this task, but we don't know what the problem was. So we can go to the web UI. I promised it might have been easy. So, okay, well, we see that we've got our job failing. Then we click through, we go and find it, do down almost to the bottom, and then I can find my Python error. But really the part which, if you're a Python user, you just want to search org.apache.spark.api.python.python exception. And then you will find the actual, and so this will wrap the confusing bits, and you can find your user. Yay! Highlighting. Oh, and these cat pictures are new cat pictures that have, these are premium grade cat pictures. Busting out special because you're Canadian. Okay, or we can go ahead and logs. And here we have a bunch of stuff about our iterators, but you know, it's not really what we care about. But you know, if we go just a few more lines down, we can find our actual error. And I mean, it's pretty clear that ignore all of the parts that are coming from inside of like rdd.py if we've got our own code at the bottom of that. If your own code isn't at the bottom of the rdd.py, you're going to have a lot of stuff to debug. But if you're lucky and it looks like this, you know, we found our monster. And our monster is, hey, mark. Okay. In Python, in Scala, it's pretty much the same thing. Our stack trace is a little bit easier to read, and we've got our exception. Now, if you ran these two divide by zero examples, you actually get two pretty different DAGs. The DAG is a really handy thing you can use when you're trying with your job. Well, it's a really handy thing if you're trying to figure out what's going on with your job. So here we can see we've got like our, you know, toy input data, and then we've got a map, and then we've got another map, and we're going to do some operation on it. In Python, the same operation is represented as input data. We do all of our work inside of this box. And inside, and this is really inconvenient if you don't know which is misbehaving, or filters, or whichever thing it is you're doing. So this is because of how Python pipelining works. It's expensive to copy data from Python back to the Java and round trip it. So instead, two operations that could be both computed inside of Python, bring the data to the JVM, we just lie to the JVM about what we're doing. And we say, I have one operation. And you don't need to know about. It's called like Python RDD. Ask any questions. And the JVM is like, sure, that's great. Well, because it gives us better performance. The only down is impossible to debug. But there's cool work around this terribleness. If your thing is failing, you can go ahead and just start RDD, forcing the evaluation of those intermediate RDDs, and then up beyond that. It'll only execute up to the point where you have. Cool. So my error was up above or down below, and then we can just do a binary search like a really slow computer. To be fair, like doing like a really slow computer over my code is kind of depressing, which is, you know, really the other option. Stack traces. If you really love reading stack traces, you know what's going on. I prefer like moving around, but I'm lazy. Lazy, you do you. It's all good. And one of the things which makes this hard to debug in both Scala and Python is that Spark makes it really easy to use, right? Like when we're writing map, all of the examples, not all, but like a lot of the examples we see provide a lambda expression, either explicitly in Python or explicitly in Scala, and it just works, right? Except all I know is my lambda expression failed, and my lambda expression failed in like 5,000 lines of code is not super clear. And so if your code is failing, you should probably refactor it so that things are separate functions. Even if it's going to be a bit kludgier to read, it'll be a lot better. And by refactoring your inner function into separate, you can add tests around them. And if you're debugging your, almost certainly a sign that you need more tests there. So a good thing. I don't guarantee that it won't hurt you because I'm factoring Unleashes Cthulhu. It's unlikely to unleash Cthulhu. And if it to put Cthulhu back in a box much faster. Due to time to expressions out when things have started to. Relatedly, please do testing. You don't SS fail vote. The SS fail, or sorry, HMS fail vote. The HMS fail vote is a very sad vote to be on. Your job fails in production 6 hours after you went woken up. I've been woken up far too many times by my own. Enough that I think other people should try to not have this happen. If on the other hand you enjoy not sleeping, I may murder you. But I'm pretty biased about it because I'm one of the, I think you should, but there's also really other cool testing libraries out there as well. How many people property-based testing? Okay, that's not everyone, so I get to talk about property-based testing. Yay! This is somewhat of an aside, but we can do to sort of prevent ourselves from going into this debugging is has coverage. And as software developers, we're really, our code is going to fail with like malformed input, right? We're like, yeah, what's going to happen if I'm given my value or it's like -6, right? We're used to thinking about like extreme values, missing values. Those things are things which make our code do bad things. So we test for them. In distributed systems like Spark, it's really important that our input data is poorly partitioned. Partitions be empty. It's really important that we test for things where like the same key, is my job going to fail? Because these totally fail in a distributed system like Spark, that or at-home system, or at home being, standalone RStudio. And so property-based testing, I don't want to think about all of the ways my Spark specific. I just want to specify some properties which are going to hold true and try and generate a bunch of test cases and see if you can ever break any of these properties. More like the number of records after my filter should decrease. Roughly the same. You might have a different property. If you're just Spark trend bit of your code like succeeding, you can have really to think about. And if you want to do like automated looking strings, like you can totally use property checking to do like weird generation of like sample input. But I think the place where we should use it is to really partition data for our tests. And checking, because I can just write a few simple things that have to be true and then magically give it to the computer to come up with test cases for me. And that sounds like a lot of less work than coming up with. If you really like writing test cases like that, then like that's cool. You make something more efficient than property checking. Generate like a lot of data and need to move it around a bunch to try and narrow down. But I think the alternative is often not. And there's a talk on YouTube with me, of course. But there's other people that have made similar libraries. My code, it's okay. You can use someone else's code. I won't. Just sad, but not mad. Okay, so that's awesome. Awesome. So the Spark logs themselves, we've seen, traces, right? But debugging just off of stack traces is not often what we want to do with our lives, right? Through an exception here, it's not all that useful logging as well, especially when we're going through the iterative debugging process. And then you're probably going to kind of have a bad time later on, right? So Spark itself, on the Java side, historically, a lot of people just directly access Spark's logger. Longer, for very good reasons. Please construct your own. Go to the same place as Spark's logs, but then you can independently control the logging for Spark itself and the logging for your application-specific code. So you could turn off the error messages from Buddy about like block over here, but leave in your logging about like, hey, I found some weird-looking data, and I think I'm going to fail. Python users don't use log4j. There are examples online where people use it. The log4j accessible worker program. If you try and use them on the worker programs, so just use Python's own logging mechanism. I should probably go comment on those Stack Overflow answers, but I don't know to do that. Has anyone used accumulators? Okay, has anyone used accumulators for things they cared about? To those three. Oh, the yarn guy. Oh, we're friends. Okay, I'm really sorry. Accumulators behave really kind of not predictably about them, but we can totally use them for one really safe place to actually use accumulators. So I think the thing about accumulators is that not all errors, right? Like if I find a malformed, I don't want to line right then, right? Because I have never had someone give me JSON data which did not have a malformed record in it. People who give me JSON schemas are almost always lying. Or maybe the people that give you the schemas for your data are always right. If you have, congratulations, surprised. But I think one of the biggest places where for us is parsing input, and so there we found, but we certainly don't want to halt our job. We want to run our job if I've rejected 99% of my input data, right? If someone upstream from me represent, and now I can't parse it anymore for 99% of the users, whatever recommendation model or system I'm building, and incidentally, I possibly cost one of my employers $1 million doing that. I feel bad about it, but you mistakes. It's much cheaper this way. And when it was mostly invalid data, but still allow it to run through when things are good. And so we can use our accumulator. In this case, pretty much fail all of the time. Because we're dividing, and that's never going to work out really well for us. But if we y and we were dividing by y, like we might only reject, 10. And that could actually be okay, right? And we want to know like records, but like we're good. That's only 200 records. Or it could be like, yeah, I probably rejected 1,000 records. Please stop and like look at my logs, and then I. That's why you have logging with your accumulators. So these two go together really well. Yeah. Okay. And in Java, just rewrite this in Java. Right. Before people get excited about accumulators, and no one seems excited, so it's okay. Really good at containing their excitement about accumulators. Accumulators is I can keep track of things that are happening. I can put side effects instead of my functional code, but I can't really relate effects being applied of time this occurred in my data. And so like this is totally, but if you're gonna like use an accumulator to keep track of that you know happened or owe someone, you're pretty on how results randomly fluctuate over multiple iterations. So like this is okay for debugging application logic. Yeah, just like you probably wouldn't play poker with that cat.
Is this a temporary situation?
Oh no. Okay. I would temporary situation. I have a pull request to consistent accumulators. That being said, there are 2 people that are qualified to review it, and one of them just really doesn't. And the other one totally cares, but Chicago. So I'm literally going to Chicago to go get him to review my code. I don't know, but like I'm working. We've been having some back and forth, but it's been like a year, so like I would not count on this being fixed anytime soon. Of course, no, this is way better.
So is it like if you're accumulating, is an off jumping 5%?
Oh no, the great not predicted. No, so it's lovely. So it is off by anywhere from like perfectly on to like several. It's unlikely to be several hundred times, but it.
Several hundred instances over, let's say we've got a.
More accurately, it's most likely within like, so if your value is like x, it's between 1x and like that's not normally a range that you can use for anything. You can use it for deciding like, oh God, something's gone bad, but like you don't give money, or you can give money to me, but you might not want to. And essentially what it comes down to is it depends on how job re-execution is handled inside of Spark. And this can unpredict because it can depend a lot on caching, and the caching is an LRU. If like one worker fails, like life becomes super unpredictable. So yeah, and like you don't even have to have a worker failure. If your data used to fit in cache, then like you could totally count this like 5 times.
Hold on, could you please repeat the question?
I'm sorry. So the question, but the question was like, how off are Spark accumulators? Is it like 1 or 2? And the answer is it's between like not off. And the other question, I don't remember. That was like minutes ago. Does anyone have a functioning short-term memory? What?
I was just asking for clarification.
Oh, okay. So it makes me happy. Makes me happy too. Okay. I'm sorry. So how many people like using? No one? Okay. If you're watching on the recording and you like Python trade, about why. Okay, let's talk about out-of-memory exceptions. How many people have had Spark give them an out-of-memory exception? Wow, is that everyone that's used Spark in the room? Use Spark, have not had Spark give an out-of-memory exception. Okay, that was. Normally, at least there's one person that's only given them an out-of-memory exception. But cool, that's awesome. So if we're in Python and our Python code is doing something that you're used to seeing, probably, except for people run Yarn Friend and other Yarn Friends. But yeah, let's look at this. So Tubbs, who is our likes United Snack Mix and coffee. I can think of all of these different pictures of Tubbs. Essentially, Tubbs is friendly. and it's going to be kind of unpredictable as to how our out-of-memory exception. If you get a JVM out-of-memory exception, like that's pretty clear what's going on, right? You've run out of Java heap space. The GC time limit exceeded, and we're sort of used to those. But for Python, you might get delightful messages like application overhead exceeded. Application exceeded. Okay, those are probably all the Python. So this error message is super clear, and I ran on a Python worker. You can also get this if you're using Tungsten off heap. Usually heap stuff. If you're like calling into Fortran code, it's really easy to go over your Yarn application container maximums. The magic does spin around, but Spark doesn't spin it. Tell us what the dial is in the error message. This, you go change your magic dial. Boom. Over like I thought they would. Of memory. So for Python users, you can even run out of memory, not doing anything that is. You tell me, I will initially blame it on you, on the mailing list, like I have done before. I'm sorry, or that was Stack Overflow. On our driver program, really wonderful bridge from Python to Java, and it will, except for the slight catch that you have two separate garbage collections, and they sort of have to cooperate, and they don't know about it, which is a really great way of cooperating, right? And so what Python is like, I don't need to garbage collect these objects, and Java's like, well, random thing named py4j seems to have references to all these objects. Keep them around, and then your program crashes, and you're like, I don't know why my program crashed. And so first I'll blame it on you, and then I'll be like, oh wait, no, okay, it's my fault. Essentially, you can manually trigger a GC clean up your Python. There's some code examples. If you run into this error, that's how you fix it. It doesn't make a lot of sense, but normally doesn't make a lot of sense. Has anyone had their Spark jobs killed by the kernel? Okay, well, we're all, yeah. Okay, I know you. That doesn't count. If your Spark jobs are getting killed by the kernel, you've probably done something Tungsten, and you should probably switch back to RDBs just from that point forward until we fix that Tungsten bug. Cool. Yeah. So reasons for JVM out-of-memory exceptions. Unbalanced shuffles is pretty common. This is really easy to have happen if you've got something with a key null, because like 90% of my records randomly have null keys, even when the client insists that their data is evenly distributed. The client always lies. Distribution of their data. Happens with Python and UDFs. If this is happening to you with data frames, essentially I minimize the amount of overhead of JVM to Python. Spark will buffer let Python do the computation and just give Python the bits it needs and rejoin it later afterwards. But it doesn't keeping track during that process, and so sometimes it will buffer more than and then promptly fall over with an out-of-memory exception. Work around it down or join in a separate stage. And individual, this says after pickling, but this could be after serialization. People with like 2 gig plus records that they then feed to the Java serializer, and then that's a really good way to you can do the same thing in Python, and this normally happens when you're just accidentally pointing to something. You've got a class and you point to another class inside of your class. This is there, but now you're trying to send, you know, your right down the wire. And, I mean, Netty's not that big, but you're trying to send something. You mean to like maybe all of your database objects and then you get sad and your job fails. Yeah, Python worker ones, that you just give more memory to Python and less memory to Java, and that with the application overhead. The other same problems. Native code memory leaks. The people who turned code back in the 60s were really good ensuring processing gigabytes of data. And in those cases, you normally just want to make smaller partitions and reset your native thing in between. And that's a pretty easy workaround. So invalid paths are like the simplest thing to do, except if they're in data frames. But I love debugging invalid paths because it just gives and that's all I have to do. And I'm like, oh look, it says my data doesn't exist. I think your problem is your data doesn't exist. The only exception is when it's like my data doesn't exist, and I go to my data's there, and then I'm like, oh dear God. If you get this error from S3, just run your job. Yeah, magical consistency layers. Guarantee, it's okay. If you get this error with HDFS, buy a support contract, or be spend a lot of time looking at XML configuration files. It's like it's doing something weird there. Right, and this is friend monster and monster. Friend monster is the JVM stack. Monster is the file that we can't find. No one else stuffed animals, but I do, so you get to hear about them. Okay, so for the fancy Java people, how many people like setting breakpoints in their IDEs? Okay, that's good. That's good. So one of the things which normally happens when we start, like, we go like, huh, I want to attach my debugger, but to what? And the answer is like, I don't know. But we can actually wonderful Java protocol to attach our debugger to a remote process. That's like, it's okay. We can tell Spark to start debugging library for us, and then we can actually connect to the worker and set the debug point, set the breakpoints, and have a lot. Awesome. I don't know why it's not in more documentation, but essentially you add this magic incantation. Whatever fancy thing it is that probably can talk to JDWP. I have this option to add suspend equals y. So if your job don't have a chance to connect your debugger before your job fails, you can be like, yo, please wait for me to get there. You probably only want to do this if you're on a single worker. Otherwise, you have to connect your debugger to every single. That's maybe going to take a while. You might want a second MacBook Pro to do that. Use to a single worker for your debugging process, and then add suspend mode equals true. So Python people, magic library. It's kind of sad, but we have other libraries, and they're also fancy and magical in IDEs. The only catch is to our invocation, we actually have to change our code to start the. And you can use a broadcast variable created during reserialization. Get remote Python debugger on all of your workers, and you can for hacks you want to do. Our code to debug it. What sucks even more is it work. If changing, there's a good chance something really weird is happening with your broadcast variables, and you want to go take a look at those. But if it changing it doesn't make it work, you can actually use this to debug it. It's sad you have to hack your code, but it's not the end of the world. If on the other hand you're like, that shit is too high class for me, just move your take one up the dependency chain until it fails and be like, starts working, and then you're like, okay, cool. I think I found my bug. Okay. And then you can, sorry. Gordon Strong found the bug. Okay. 8-bit music. Okay, well, I'll send it to you. It has inappropriate, otherwise I would play it, but it's about finding the bug. This comes after that. There's a question mark and underpants gnomes. Anyways, the other option is you can just sample your data. Honestly, I can mode is a pretty good fidelity to the distributed mode. So much easier to attach a debugger to one process. Miles easier. The only problem is at least like 50% of the problem only repros in cluster mode, and that's just life. So you can't always use this. It's a good instrument. And you should buy many books. Yay! You should buy all of these. I only receive royalties for many copies. If you have a corporate Amex, you can buy several copies of this. Corporate Amex, you can still buy several copies, but it'll be more understanding if you don't. Denny, if you're one of the people that was just getting started, Denny and Tomas have a Learning PySpark book coming out. If you're a Python user, this is the Python that I know of. There might be another one, but I owe Denny a beer, so you should buy a beer. Oh, right, and the one that, unless you just want to give me money. If you can, you can buy this book. Can't accept bribes. I fully comply with our corporate promise. And just, you know, if you want to buy that book where I receive the most royalties, it's really easy to. You can go right here. And convenient. So it is so much easier for me to give you, for you to give me that wrong. Yeah, you can give me money, just go here and get into a right, and they will forward a check to me. Section is in the appendix. It is not yet available, but if you care about like just scaling your Spark jobs, and a lot of really, as a co-author, good advice, but you know, whatever. So that's pretty much good. Okay, ignore this part. The rest of it though. Thank you so much for coming. You didn't seem to like any of my jokes though. What's that? But thank you for putting up with them anyways. Does anyone have any questions or anything? Sleep. We can. Oh, question.
Sorry, one second.
Oh, fancy.
I have a quick question. In Spark, in logging, it's as part of the information that it provides the.
Yeah.
Is it okay? Can you decide what does it mean? Size like a specific amount of log.
Okay, sure. Let me come take a look at your log message.
Yeah.
This is the number of bytes from the RDB. Just gonna go to that thing.
Okay. This amount includes some amount of data.
Totally possible. So this
Can
amount,
you give? Because I saw it and I wondered from where this extra volume comes.
for sure. Comes from sort of the pickling overhead. So what happens is are essentially transferred in serial from Java Python, and so these bytes here are essentially like the pickled representation, plus like a few bytes of sort of like information about. So there's like the task context. I don't know if the task context information is included in this bike, but that could, I don't know. But certainly the pickling overhead would very much account for this being different.
And how much is the, like, how much bigger how much, like, is it twice or?
It's really hard to say because of pickling and if there's an efficient representation for it, but twice is quite possible. If it was more than 10 times, we go investigate. If it was under that, I would probably be like, eh. But relatedly, I make more money. So like, yeah.
So you mentioned and connecting the executors.
Yeah.
To all, could you just connect to the executor that actually has the issue?
Right. So if you add suspend equals y, the other executors aren't going to start, and so this isn't done per task, right? Inside globally, and so Spark is if you only connect to one of them, essentially only one of the executors is going to become a lot, and like all of your jobs are going to get scheduled on that machine, and you're going to have a bad time.
Okay.
After a job finishes its execution, it's possible to see the logging.
Yes, it is.
How can we keep all those logs?
Okay, wait. So are you in Yarn?
No, by Spark.
Well, no. So what kind of cluster do you deploy on?
Even
Oh, in local mode.
debugging in local mode.
Let's pretend you have a Yarn cluster, and if you don't,
We have, let's say, Amazon.
you can install Yarn.
We can imagine that.
You can totally do this in Yarn. You just like turn on, and then I'm gonna go store these, and then you can enable the Spark there and like click on things in the history. So like install Yarn.
Have Yarn, there is no way to do it.
You can get it for free. And so there probably are other ways to do it. So like if the Mesosphere people were here, how to do this on DCOS or Mesos, but Amy, we figured that part out.
What do you think?
Are you sure that we can ever do it? I think at someone needs to do that.
Yeah, so the question is, are you sure you can? And I think you can make it keep standalone mode. I don't remember how. I can do it in Yarn by setting one flag to true. Like, I set that flag to true. It's like so much less work than figuring stuff out.
Try and standalone. And there's a temp directory where that's where I want to look for the logs. But yeah, I agree that is. Yeah.
Hi there. Two questions. One point. Number one, if you're using Amazon and could it give you Yarn and the Spark history server for free? And another question for you on better data.
Yeah.
So I completely understand the tricks that Spark has to do due to the performance issues of going back and forth between the JV. Or you got Arrow, and would you consider that improving drastically?
I this person, but thank you for asking that question. Yeah. So arrow support is certainly, I mean, I can't make any guarantees because I'm not like Matei or Reynolds, but the Arrow just released their 0.2 release, which we've been waiting on. I'm going to work really hard to try and get it in soon. That's working on that PR. I don't know where he lives, but I do in the same office that I ostensibly work in. So I can harass him until he finishes that PR. So arrow support, I can't promise you this, but I can get in to be as sad as you are. As far as arrow support being used to make it tag is like full-fledged, arrow is still not free, and keeping data in Python is free. Arrow's performance is pretty good, but it's not. And right now, right now we're stuck. Arrow is totally, I really want it to be coming as well. I'm working, or more specifically, my coworker is working on it, and I harass him. Whatever job title I have, I totally count as work. So yeah, yay. If anyone like knows Wes, please buy him coffee. He's amazing. One other challenge though is like this, and Arrow is really the data frames we think, but because RDBs have to contain object, we're pretty much out of luck with putting Arrow in for this. But like 2 times. Yeah.
All right, thank you. Any more questions? No, Holden, thank you very much. It was a great talk.
Oh, no, thank you. I really appreciate it.
Thank you, Holden. On behalf of the fantastic organizers of the Spark meetup, Armando, I want to present you with courtesy of our friends from Databricks, go in the house. Thank you so much. This
has some of these from also, hi, former employer. I will, yeah, thank you.
Awesome. Thank you. Awesome. So Holden will be sticking around for. Let's get to know each other. Certainly, there are a lot of